Let's take a look at the first example. It says, suppose that the relation H is defined as follows. H equals the set containing the ordered pairs -6, -8, 8, -2, -6, 7, and 0, 8. A relation is simply a set of ordered pairs. It says give the domain and range. So when we're discussing relations and functions, the domain are the x values. So the domain would be the x values. So in this case, if we're using a set to represent our domain, we include each value. So -6, 8, we've already said -6, so we don't duplicate, and 0. So that would be our domain. Our range would be our y values. So in our ordered pairs, the second value, of course, would be our y values. So we'd have -8, -2, 7, and +8. So again, our x values would be our domain, and our y values would be our range. Our next example, it says for each relation, decide whether or not it is a function. So remember, all a relation is a set of ordered pairs. For it to be a function, each domain value can only relate to a single range value. So when we look at the first example, relation 1, we have cloud, leaf, pencil, and tree being the domain, and our range being -3, 7, and 8. Notice that cloud only goes with a single range element. Leaf only goes with a single range element. Pencil also is only with a single range element. And tree also only goes with a single range element. So since each one is only paired with a single range element, then that would be a function. When we look at the next example, -3 is paired with -1, and -3 is also paired with 9. So in this case, since -3 is paired with more than one range value, it would not be a function. Again, -3 is branching to two separate range values, therefore it is not a function. Let's look at a couple of other examples using ordered pairs. So relation 3, in order for this to be a function, the domain value, the first value, cannot repeat. So we notice that each one of our ordered pairs has a separate domain value, or first value, or x value. Therefore, this would be a function. In the next example, we notice the domain value 5 repeats. And when it repeats, it's with a different range value, f, then u, than y. Since the domain value repeats with a different range or y value, this would not be a function. Now, anytime we're given graphs and we're asked to identify whether or not it represents a function, we use something that's called the vertical line test. So keep in mind the definition of a function. A function is a relation where each domain value corresponds to a unique or single range or y value. So in the vertical line test, if we draw a vertical line and it intersects the graph in more than one place, then it is not a function. So when we look at this first example, when I draw a vertical line, notice that it intersects this graph in two different places. Therefore, it's not a function. Our next example, if I draw a vertical line, notice when I've drawn it in a few places, it's only intersecting the graph in a single location. Therefore, that would be an example of a function. Now graph 3. When I draw a vertical line, again, it intersects the graph in more than one place. Therefore, it's not a function. So if it intersects in more than one place anywhere on the graph, it's not a function. So graph 4, the open circle, the white that's not filled in, represents a starting point but doesn't include that point. So even though it looks like when I draw the vertical line through this, it intersects it in two places, it doesn't, because the open circle does not include that actual point. Therefore, since I can't draw a vertical line anywhere where it would intersect the graphs in more than one place, this would be a function. Okay, same for the next example. There's nowhere where I can draw a vertical line through a point and it will go through another point. Therefore, this would also represent a function. Now the next example, although all of the points with the exception of one, a vertical line would only go through one point, this would not be a function because when I draw a vertical line here, it passes through these 2 points. Therefore, that would not be a function. Now, when we're given an equation and we're asked to identify whether or not it's a function, all we need to really do is pay attention to the y variable. If the y variable is squared, then it's not a function. X can be squared, X can be raised to any power, but Y has to be Y to the first power in these examples. So the only case would be the third case where it has Y squared equals negative 3X. Would it not be a function? So the first Y equals 6X, this is what we call a linear function. We'll talk about more later. So that would be a function. Y equals 3x plus 5. Again, it's just y to the first power. This is also a linear function. And the last one we call a quadratic function. Anytime x is raised to the second power, and this would also be a function. So again, just pay attention to the y variable. If it's raised to the second power, then it would not represent a function. Now let's get into some problems where we're going through a process called evaluating a function. So when we're evaluating a function is given to us or defined for us, and we're just going to plug in a value for the variable in the given function. So the given function is 30g. The d of g, that first part, is just the name of the function. We're not doing anything to that part. So anytime we see that, that's function notation. That's the same thing. That d of g is the same thing as y equals. But d is the name of the function. So it's d of g is, notice we have g as the variable in the function. So all we do in these cases is substitute the given value into that function for that variable. So in this case, it says Keisha is driving on a highway. She uses 1 gallon of gas every 30 miles she drives. So that's where we have d of g equals 30g, 30 representing the miles she drives per gallon. The distance d in miles she travels on g gallons of gas. Notice g represents the gallon of gas. So now we're going to evaluate for the given function. How far does Keisha drive if she uses 4 gallons of gas? So all we do in this case is simply substitute 4, number of gallons, in for g. So we still have 30 times 4, which would give us a distance of 120 miles. Okay, in the next case, they're not giving us a word problem. They're defining the function for us. So they say the function h is defined as follows. H of x, remember the h is just the name of the function. The x is the variable used in the function. Notice it's x minus 5 in the numerator and x plus 12 in the denominator. That's why it's h of x. Now it says find h of negative 8. So again, notice the negative 8 replaced the x. So it will replace the x in the function. So now when we are evaluating the function, instead of it being x minus 5, we're going to have negative 8 minus 5 in our numerator. And in our denominator, instead of x plus 12, remember the negative 8 replaces the x. So we'd have negative 8 plus 12. So negative 8 minus 5 in the numerator is a negative 13. And in our denominator, we have negative 8 plus 12, which is 4. So it says simplify your answer as much as possible. That just means to reduce the fraction. Leaving it in this form is totally fine. So our next problem says the functions f and g are defined as follows. Remember, the f and g are just the name of the function. So f of x equals negative 2x to the third power minus 5. G of x equals negative 2x minus 3. We have two different problems to do. So it says find f of negative 2 and g of 4. So remember, the f is the name of the function. So what it's telling us to do is use the f function and replace negative 2 in for x in the f function. So we'd have negative 2. Instead of x, we're going to put in that negative 2 to the third power minus 5. So negative 2 to the third power is negative 8. And we still have this negative 2 up front. And negative 2 times negative 8 is positive 16. So we have 16 minus 5, which is 11. So f of negative 2 equals 11. Now we have to find g of 4. So again, that letter tells us which function to use, so we're going to use the g function. And the 4 replaces the x in the function. So we'd have negative 2 times 4. So instead of it being negative 2x, it's negative 2 times 4 minus 3. So negative 2 times 4 is negative 8 minus 3. And negative 8 minus 3 is simply negative 11. In this next problem, again, we're asked to evaluate, in this case, a rational function. Just means we're dealing with fractions. And it says h of x equals x squared minus 4x minus 5 over x squared minus 6x minus 16. And it asks us to find h of 7. So again, h is the name of the function we're going to use, and we're going to replace the variable, in this case, x, with 7. So now, this would be 7 squared minus 4 times 7 minus, in this case, 5. So all I've done is replace the x in the numerator using parentheses with the 7 that was given in the original problem. So in the denominator, the same thing. So I have x squared, so that changes to 7 squared minus 6 times 7 minus 16. So in the numerator, 7 squared, or 49, minus 4 times 7, which is 28, minus 5, over, in the denominator, I have 7 squared, which is 49, minus 6 times 7, which is 42, minus 16. So in the numerator, I have 49 minus 28, which is 11. Excuse me, it's 21. And 21 minus 5 is 16. So again, 49 minus 28 is 21, and 21 minus 5 is 16. In the denominator, I have 49 minus 42, which is 7, and 7 minus 16 is negative 9. So my answer would be negative 16 over 9. Okay, for this next example, we're doing division of functions. So there's a couple of different ways to do this. So in this case, it's given us h of x equals x minus 3 and g of x equals x plus 4 times x plus 6. So one way to do it is to set it up as the h function over the g function to begin with. So that means we'll make it x minus 3 over x plus 4 times x plus 6. And just as we did in the last problem, now we can substitute the 4 in for the x in both functions. So that would give us 4 minus 3. And notice I have parentheses, 4 plus 4 times 4 plus 6. So 4 minus 3 is 1. And in the denominator, I have 4 plus 4, which is 8. And 4 plus 6, which is 10. And my numerator is 1. And then I'm just going to multiply the two values together. So 8 times 10 is 80. So my answer would simply be 1 over 80. Now the second one, we're going to deal more with domains later, but this says find all the values that are not in the domain. So the values that are not in the domain, when we're talking about rational or fractions, rational functions or fractions, are just the values that make the denominator 0. So we know that if we plug negative 4 in for the first factor, that would make this 0 because negative 4 plus 4 is 0. So negative 4 has to be one of the values not in the domain. And the second value not in the domain would be the value that would make the second factor 0. And negative 6 plus 6 is 0. So -6 would be the other factor that would not be in the domain, or other value not in the domain. And again, we'll talk about that in more detail later on. Our next example is we're going to be dealing with 3 different operations. We're going to be dealing with subtraction of functions, addition of functions, multiplication, and evaluating the function after we multiply. So here we have r of x equals x minus 3. I always think it's a good idea to put it in parentheses. It will keep you straight when it comes to the signs. S of x is 3x plus 1. So for the first problem, where we have r minus s of x, we put the r function first, which is the x minus 3. And we're going to subtract from that the s function, which is 3x plus 1. Now we remove parentheses. So if nothing is in front of parentheses, there's nothing in front of the x minus 3. That just becomes x minus 3. In the second group, since there's a minus sign in front, it changes both signs. So the 3x becomes a minus 3x, and the positive 1 becomes a negative 1. And our last step would be to combine like terms. So we have 1x minus 3x, which is negative 2x, and we have negative 3 and a negative 1, which gives us a negative 4. For the second problem, the addition problem, we're adding the two together. So again, I write my r function, which is x minus 3, plus my s function, which is 3x plus 1, and now get rid of parentheses. So remember, if nothing's in front, I just drop the parentheses. Also, if there's just a plus sign in front, everything stays the same. So that stays a positive 3x, and that stays a positive 1. And we add the two together, so we have 1x plus 3x, which is 4x, and negative 3 plus 1, which is a negative 2. So for the next problem, we're going to find the product, or we're multiplying the two together. Now, I talked about an alternative method in the previous problem, and we can use that here as well. And so let's talk about what the method is. Since 3 is replacing the x in the functions, what I can do is evaluate the functions first. So in other words, I can find r of 3. So that means I'm substituting 3 in for the x, and that becomes 3 minus 3, which is 0. And I also can do it for the s of 3. So the 3 is going to replace the x, so that becomes 3 times 3 plus 1, which is 9 plus 1, which equals 10. So again, I just substituted the given value in for the x's of each function, and now to get the answer, I can simply multiply the two values together. And 0 times anything is 0. The other method is you would have to multiply the two together first. So you would have the x minus 3 times the 3x plus 1. And you could either FOIL here, or again, you could just substitute in the value 3. So in other words, I would make that, instead of x minus 3, 3 minus 3 times 3 times 3 plus 1, and that gives you the same thing, 0 times 10, which again would simply be 0. So there's more than one way to work some of these problems, and either way will yield the same result. So now in some cases, we're given a variable included into what we're substituting into the function for the variable. So in this case, same thing. We have f of x equals 3x squared plus 4, and we're asked to evaluate f of 4x. So again, whatever's inside parentheses replaces the x in the original function. So instead of it being 3x, it's 3 times 4x squared plus 4. Order of operations, we do the parentheses and the power first. So 4x times 4x is 16x squared. And now I multiply 3 times 16x squared, which is 48x squared, plus 4. So the next problem, we're dealing with what's called a piecewise function. Notice we have two different equations or expressions that represent a given function. So it says f of x equals 1/4 x minus 1 if, so here's the restrictions, if x equals -2. X does not equal -2. So if x doesn't equal -2, you plug the value in for x for 1/4 x minus 1. And it says if x does equal -2, then your answer in this case is simply 3. So here we're given 3 different problems to do. So it says first evaluate f of -5 given this piecewise function. So we come to the restrictions. Since -5 represents x, it doesn't equal -2. -5 doesn't equal -2. So we have to plug it in to the 1/4 x minus 1. So what we'll have is 1/4 times -5 minus 1. So we have to evaluate. So this becomes -5/4. Because remember, you're just multiplying numerator times numerator and denominator times denominator, minus 1. And in order to combine these, we need a common denominator. So our common denominator is 4. So we have -5/4 minus 1, or -5/4 minus 4/4. Because remember, 4/4 is the same thing as 1. So we have -5/4 minus 1, which becomes -5/4 minus 4/4. And all we do is combine our numerator, and this becomes -9/4 for our answer. So now we come to the next and look at our constraints. It says evaluate f of -2. Since x equals -2, we deal with the second function. So it just says if f equals if x equals -2, then our answer is simply that. In this case, it's 3. So there's nothing that you needed to do. So for our last one, it says we're going to go ahead and look at f of 3. Well, we know that 3 does not equal -2. So again, we have to use the first. So it's 1/4 times 3, or 3/1, minus 1. So multiplying straight across, we have 3/4 minus 1. And remember, we have to get a common denominator. So that's 3/4 minus 4/4, because 4/4 is 1. And now again, we combine the numerator. 3 minus 4 is -1, and our denominator remains the same.